Assalamu alaikum students. Today's lecture is arranged by Radiant Secondary School and the topic of discussion for today is relative atomic mass and atomic mass unit. So first of all we will discuss about relative atomic mass. So before going into the depth of the definition of relative atomic mass, we should consider some important points as discussion. So first of all, atomic mass is a quantitative information about an atom, and the most important work on providing this quantitative information was done by some famous scientists like Dalton, Gay-Lussac and Avogadro in 19th century. These scientists observed that how elements combine to form different compounds. Now we all know that atom is an extremely small particle. Okay? Atom is an extremely small particle, and practically it is impossible to find or to measure the atomic masses of these atoms because we don't have any method or any weighing balance to weigh or to measure their atomic masses. So how do we find their atomic masses? Okay? So it is possible to measure the mass of an atom relative to another atom experimentally. Okay? It is possible to measure the mass of an atom relative to another atom experimentally, which means that we have to fix an atom as a standard, and then we will measure the atomic masses of other elements by comparing with that standard atom. So in 1961, by the international agreement, the light isotope of carbon-12 was considered or was chosen as a standard for measuring the relative atomic masses of all other elements. Now, carbon basically has three isotopes, carbon-12, and the rest of two are carbon-13 and carbon-14. But why the scientists selected or chosen carbon-12? The reason is that the carbon-12 is the most abundant isotope as compared to the other two isotopes, that is carbon-13 and carbon-14. Moreover, the atomic mass of carbon-12 is exactly 12 on periodic table, which makes it a perfect choice to make it as a standard. So considering all of these points, now we are able to define relative atomic mass. So how can we define relative atomic mass? Relative atomic mass is the mass of an atom of an element relative to the mass of an atom of carbon-12. Okay? The mass of an atom of an element relative to the mass of an atom of carbon-12, which means when we compare the atomic mass of an element with carbon-12 isotope, that atomic mass actually is its relative atomic mass. Now, for example, the atomic mass of oxygen is 15.99 AMU and the atomic mass of chlorine is 35.45 AMU. Okay, you can check these atomic masses from the periodic table. Now, these atomic masses are basically called as relative atomic masses because these have been found or measured by comparing it with carbon-12 isotope. So this is called as relative atomic mass. Okay? Now, the relative atomic mass is basically measured in a unit which is called as atomic mass unit, and it is represented as AMU. Now, we are going to discuss atomic mass unit, which is basically related to the relative atomic mass. It is the unit of relative atomic mass in which the relative atomic masses are measured. Now, how will we define atomic mass unit? 1 AMU or atomic mass unit is the mass exactly equal to 1/12 the mass of carbon-12 atom. I am repeating the definition. 1 AMU or atomic mass unit is the mass exactly equal to 1/12 the mass of one carbon-12 atom. So we can simplify this whole definition by this simple formula, that is 1 AMU is equal to mass of one carbon-12 atom divided by 12, which means when we divide the mass of one carbon-12 atom with 12 We get one answer because 12 divided by 12, it is 1, and it has given a unit of AMU. So this is the definition of 1 AMU, or atomic mass unit, which is the mass exactly equal to 1/12 the mass of one carbon 12 atom. Now here we will discuss example of hydrogen atom, and we will calculate its atomic mass unit by comparing it with carbon 12 isotope. Now hydrogen atom is 8.40 as massive as standard carbon 12. Okay, so you have to first understand this statement, then you can calculate its atomic mass. Now this means as we have set carbon 12 as a standard, so on a scale carbon 12 is considered as 100. Okay, so when we compare the masses of hydrogen and carbon, we can say that the hydrogen atom is 8.40% on among that, in that 100%. Okay, so by applying the formula 8.40, which is the percentage of hydrogen, massiveness of hydrogen, divided by 100, which is the percentage of carbon, multiplied by 12. So by calculating this whole value, we get an answer of 1.008 AMU. This is the relative atomic mass of hydrogen, and it is represented as a unit of AMU, that is atomic mass unit.
Mass is the mass of an element in relation to carbon 12. The reason that this is the isotopic mass is because some elements have different isotopic forms. For example, chlorine can be found as chlorine 35 and chlorine 37. The isotopic mass is not the mass number which appears on the periodic table. The number seen on the periodic table is the relative atomic mass, or the AR. The relative atomic mass of an element is defined as the average mass of the naturally occurring isotopes of the element relative to the mass of an atom of carbon 12. On the periodic table, it is the same number as the mass number. In basic terms, it is the average mass of the isotopic forms of the element. When we think about this, we must remember that isotopic forms of elements have different values for their naturally occurring abundance on Earth. For example, let's look at the isotopic forms of chlorine. Some chlorine atoms have a mass of 35, and some have a mass of 37. In most cases, to take a simple average, you would just add the values together and then divide by the number of values. In this case, it would be 35 plus 37 divided by 2, and you would get an average of 36. But this is not how you calculate the relative atomic mass. We need to remember that we are talking about number of atoms. There are a certain number of chlorine atoms with a mass of 35 and a certain number of chlorine atoms with a mass of 37. However, within a sample, the levels of each isotope are not equal. So we take this into account when we are calculating the relative atomic mass, so that we are calculating a weighted average. Naturally occurring chlorine is made up of 75% chlorine 35 and 25% chlorine 37. This can be shown to you on a graph to show abundance data, where the relative isotopic mass is shown along the x-axis and the relative abundance is shown on the y-axis. So say we had a simple sample of 100 atoms of chlorine. We would have 75 atoms of chlorine 35 and 25 atoms of chlorine 37. We first find out the total mass of the sample. We do this by multiplying the mass of each atom by the number of atoms present for each isotope, and then we add them together. For chlorine 35, there are 75 atoms, and for chlorine 37, there are 25 atoms. So the mass of 100 atoms would be 75 times 35 plus 25 times 37, 3,550. The mass of one atom will be the mass of the total number of atoms divided by the number of atoms. So the mass of one atom of chlorine would be 3,550 divided by 100, 35.5. The relative atomic mass has a value closer to 35 because there are more atoms of chlorine 35 than chlorine 37. It is a weighted average. So the relative atomic mass of an element is defined as the average mass of the naturally occurring isotopes of the element relative to the mass of an atom of carbon-12. On the periodic table, it is the same number as the mass number. The number is a weighted average, and when calculating its value, the proportion of an isotope in a sample must be taken into account.